This video is intended to be a quick introduction to what's called the factored form of a quadratic. All quadratic equations can be put in what's called factored form, which is the product of two linear factors. In fact, my linear factors here have leading coefficient here 1, and they are linear. So x minus r is a linear factor and x minus s is a linear factor. The advantage of doing this is it will be really easy to figure out what the zeros of the equation are. The zeros of the equation are simply the x values that make the output 0, and then they correspond to the x-intercepts if you were to graph the parabola. The other thing that's easy to tell is the concavity of the parabola once you put it in this form. So for example, if you were to take this quadratic equation and factor it, I'm not going to show that in this video, but if you were to factor it as follows, this is what the analysis would go like. Since a is 3, the fact that 3 is positive means that the graph would be concave up and look like a U-shaped curve as you see here. The fact that x minus 1 came out to be the factor means that one of the zeros is the opposite of that in sign, meaning since this is a minus 1, one of your zeros is going to be positive 1. And the reason that works now is if I was to plug in positive 1 in for x, remember what a 0 is, it's the x value that makes the output 0. By changing the sign from negative 1 to positive 1, look what happens here. Replacing x equals 1, I'm claiming that's a 0, into the function, this factor would yield 1 minus 1 or 0, and then you can see 0 times 3 is 0, and it won't matter what this factor comes out to be at x equals 1, comes out to be 4, but it doesn't matter because once this is 0, 0 times anything is 0, guarantee me that my output would be 0. So we say x equals 1 is a 0, and remember what it is, it's the x value that makes the output 0. So if you label that as a point, you see that that turns out to be an x-intercept on the graph, so this x-intercept is 1, 0 here. Lastly, the x plus 3, if you would do the same thing and change the sign to minus 3, the same story would hold. If someone were to plug negative 3 in here, they would get negative 3 plus 3, which is 0. Doesn't matter what this comes out to be, because 0 times anything is 0. So having negative 3 as an input guarantees my output will be 0. And then in point notation, you see that that would put a point right here on the x-axis, so that creates the other x-intercept. If you want, here's another quick example, a little bit more convoluted. It's more difficult to put it in the desired factored form. If you remember right, I said that the factored form has it such that the numbers in front of the x, those coefficients, are a 1. Sometimes that's a little tricky. So for example, in this quadratic, I factored it in the traditional way to get this. But if you look at it, my coefficient on x is 2, and this coefficient is 3. So I pulled this algebraic maneuver where I divided both these this factor through by 2 to get this. I divided through on this factor by 3 to get this. That made the coefficients 1. But since I divided by 2 and I divided by 3, I had to compensate it by multiplying by 6 to make these two equations equivalent. But nonetheless, I have it in this form. I see that a is positive again, so notice my graph is concave up. Notice that if you change the sign here, you would get a fraction, but that's fine. Your 0 would be negative a half. If someone plugged in negative a half, you'd get negative a half plus a half, which is 0. And again, 0 times the other factors would yield an output of 0. So down here in point notation, since negative 1/2 is the 0, it's the x value that makes the output 0. That shows up as an x-intercept on the graph. And then the last factor here, x minus 5/3, if you were to change the sign, you'd get x is 5/3. So it is a 0, so that's here. And by definition, it's an x value that makes the output 0, making it an x-intercept on the graph. What you see here is just a decimal approximation to 5/3.